Good morning, students. So we are studying about determinants. In the determinants, based on properties, we are solving the examples based on properties of determinants. So in that, up to example number 10 from your NCERT textbook, we have finished. And today, we discuss about example number 11. By using properties of determinant, prove that first one, determinant of a minus b minus c 2a 2b b minus c minus a 2b 2c and c minus a minus b is equal to a plus b plus c whole raised to 3. Okay. So consider LHS here. LHS. This is LHS. Write once again. A minus b minus c 2a 2b b minus c 2b here 2c c minus a minus b. To apply properties, before applying properties, we should know what is required. Means the right hand side we require a plus b plus c whole raised to 3 required, means we should get a plus b plus c. So for that, which operations we can apply here to get a plus b plus c? Here the first row a minus b minus c is there. We need to make it as a plus b plus c. How it is possible? If you apply the operation R1 implies R1 plus R2 plus R3. What will happen? Here 2b is there. If you add this 2b, here a minus b plus 2b, it will be plus b, minus c plus 2c, it is plus c. Here also it will be same. 2a plus b minus c minus a plus 2c is there. 2a minus a plus b minus c plus 2c plus c will come. Similarly, the third column also. So LHS is equal to, after simplification, we will get a plus b plus c only, right? Here also same a plus b plus c. It is also same a plus b plus c. Remaining as it is 2b b minus c minus a 2b. Third also as it is 2c c minus a minus b. Okay. Next, in the first row, a plus b plus c is common. Take it outside. A plus b plus c is common in the first row. 1 then 2b b minus c minus a 2b 2c, these also 2c c minus a minus b. Then next thing is, make these two as 0. If you make them 0, it will be easy for calculation. For that, C2 or C3 implies C3 minus C1. Okay. C3 implies C3 minus C1, or C2 implies C2 minus C1. Okay. Here A plus B plus C. Then first column as it is 1, 2B, 2C as it is 1 minus 1, 0, because C2 implies C2 minus C1. Here 2b is there. C2 minus B minus C minus A. Okay. B minus C minus A minus 2B. So it will be minus B minus C minus A. 2C minus 2C, it is 0. Here again, third column. Again, C3 minus C1. C3 minus C1 means 1 minus 1, 0. 2B minus 2B, it is also 0. C minus A minus B minus 2C. Here it will be minus C minus A minus B. Okay. Then which is equal to, by the property here, one side of the principal diagonal. Okay. One side of the principal diagonal, each element is equal to 0. Then we can write the value of determinant is equal to, the value of determinant is equal to the product of principal diagonal elements. We need to take the product of this. Here minus is there. If you take minus outside, minus of A plus B plus C, or else B plus C plus A. Here also same. Minus is there. Take minus outside. Minus of C plus A plus B is nothing but A plus B plus C. Which is equal to A plus B plus C. Minus into minus plus. So A plus B plus C. A plus B plus C. So all rest A plus B plus C. All rest. That is answers. Same by using properties. One more to that. Some question. Same type. X plus y plus 2z. Here x is y. Z y plus z plus 2x. Then y. Next z x. Z plus x plus 2y is equal to 2 into bracket x plus y plus z whole cube. Same type. Here also, to get right hand side, 2 into bracket x plus y plus z whole cube. Which operations we can apply to the left hand side? So let us consider LHS part. X plus y plus 2z, x and y, z, y plus z plus 2x. Here y, z, x, z plus x plus 2y is there. If I take C1 implies C1 plus C2 plus C3, because we cannot take rows here. If I consider rows, z plus z, 2z, 4z will come, then only x plus y will remain. So if I consider columns, here x is there, here also x is there, x plus x, 2x will come, here y is there, 2y will come, then 2z will come. So similarly, from remaining two columns also, if you add these two elements, two first column elements, we will get x, 2x plus 2y plus 2z. That's why C1 implies C1 plus C2 plus C3 we have considered. So adding the first column, x plus x to x, y plus y to y, and then 2z as base. Here z plus z, 2z, y plus y, 2y, 2x as base. Again 2x plus 2y plus 2z. And last z plus z, 2z, x plus x to x, and 2y. It is also 2x plus 2y plus 2z. Then xy, y plus z plus 2x, then y, x, z plus x plus 2y. Okay. Then what is common? In the first column, 2x plus 2y plus 2z is common. Take it outside. 2x plus 2y plus 2z, which is common. Determinant 1, 1, 1, x, y plus z plus 2x. Here x, y, y, z plus x plus 2y. Is it right? Then making these two as 0. Into bracket x plus y plus z whole cube will be required. So to make them 0, R2 implies R2 minus R1. Then R3 implies R3 minus R1. Then LHS is equal to, here 2 is common. Like 2 outside, inside x plus y plus z. Determinant first row as it is 1 x and y. Second row, because we are operating on R2, R2 minus R1, 1 minus 1, corresponding element. 1 minus 1 is 0. Y plus z plus 2x minus x. That is y plus z plus x only. Y minus 1. 0. Then 1 minus 1, 0. X minus x, 0. Here z plus x plus 2y minus 2y means z plus x plus y. Is it right? And again, one side of principal diagonal. This is principal diagonal. Below that principal diagonal, these three elements are 0. So each element of one side of principal diagonal is 0. So the determinant, the value of the determinant is product of principal diagonal elements. Product means 1 into x plus y plus z into x plus y plus z. Correct? Is equal to 2 into x plus y plus z whole cube. Okay. Next step now. Just we are applying the properties and operations. For using properties, we are solving the examples. For that, we should know about the properties of determinants. There are 8 properties. You should remember them. And operations also. Next example, question number 12. Same again, using properties. Using properties, prove that determinant of 1 x square, 1 x square 1 is equal to 1 minus x cube whole square. Okay, 1 minus x cube is required. So 1 minus x cube, you should know the formula of a cube minus b cube. A cube minus b cube means a cube minus b cube. What is the formula? a cube minus b cube, that is a minus b into bracket a square plus ab plus b square, right? So if I get a minus b into a square plus ab plus b square also, it is nothing but a cube minus b cube. Here in place of a, 1 is there. In place of b, x is there. You can put that 1 minus x into 1 plus ab means x plus b square is x square. Okay, means we should require 1 plus x square also. Then 1 minus x. If you take the product of these two, we get 1 cube minus x cube. We get, right? Whole square is there. That will see later. So that first we will consider LHS 1 x square. X square 1 x square 1 is there in the LHS. Then to get 1 plus x square, now write like this: c1 implies c1 plus c2 plus c3. Okay. So c1 1 plus x square, c2 also like that 1 plus x square, because x square plus 1 plus x is equal to 1 plus x square. Here also said x square plus 1, it is nothing but 1 plus x square. Then remaining x1 x square as it is, x square x1. Then 1 plus x square is common, take it outside. What will remain? 1 x1 x square, then x square x1. Simplify. Again, same as the previous example. Here we need to make these two as 0. 1 1 we got now. It's very easy to make them as 0. For that, R2 implies R2 minus R1 we get. R3 implies R3 minus R1. Okay. Then 1 plus x square. Determinant 1 x square. 1 minus 1, 0. 1 minus x, that is 1 minus x minus x square. Next 1 minus 1, 0. X square minus x, then 1 minus x. Again simplification. One plus x square. Determinant 1 x square is that 0. Here 1 minus x will get. Okay, here we record 1 minus x only right now. For that, if I take x common here, inside what will remain? 1 minus x. Here also say, if I take x common, minus x common, if you take a minus x common, here also 1 minus x will remain. Here also 1 minus x. Now, from the second row, 1 minus x take outside, and third row also 1 minus x is common, each other. Okay, 1 plus x square. 1 minus x from second row, and one more 1 minus x from third row, taking common. Remaining 1 x square, 0, 1, here x will remain, here 0, here minus x, 1 will remain. Next, now expand through first column, expand through first column. First column because zeros are more in first column, that's why expand through first column. It will be 1 plus x square. It is 1 minus x whole square. Then, if you expand it to the first column, 1 into bracket 1 minus of minus means plus x square. Next, minus x into leave this column and row 0 0 will get, it will be 0. Then next, x square something wrong here. 1 minus x square minus 1, x square minus x, 1 minus this. Here should be 1 minus x square because r3 minus r1, r3 is 1, r1 is x square, so 1 minus x square will come. 1 minus x square means you can write it as 1 plus x, 1 plus x into 1 minus x, that is 1 minus x square. After taking 1 minus x common, here 1 plus x will remain. Okay. Then for 1 plus x square remaining 0, 0 plus 0 here is equal to 1 plus x square, 1 plus x square. We can write it as 1 plus x square whole square, 1 minus x whole square. Or else we can write it as 1 plus x square into 1 minus x whole square. It is nothing but RHS, that is 1 minus x cube whole square. Okay. This is example number 12. Here operations, next properties, again operations, again properties. Okay. Then properties here, then simplification. This is procedure for solving the examples by using properties. And lastly, examples, set of examples for 4 marks. In one examination, 4 marks question it is. Question number 13. Same again, by using properties, prove that. By using properties, prove that 1 plus a square minus b square 2ab minus 2b 2ab 1 minus a square plus b square 2a, then 2b minus 2a 1 minus a square minus b square is equal to 1 plus a square plus b square 1 plus a square plus b square whole cube. Here right hand side we require 1 plus a square plus b square for that. Let us consider LHS again. LHS 1 plus a square minus b square 2ab minus 2b 2ab 1 minus a square plus b square 2a 2b minus 2a, 1 minus a square minus b square. Okay. Now, here, to make them as 0, what will happen? C3 implies, to make it 0, here AB is there, here also make it as A, product by A into C3, then add it to C2. C3 implies A into C3. So what happens here? If you multiply, then 1 by multiplication and divide third power. That's why 1 by A will become 1 plus A square minus B square. First column as it is 2A, 2B, then 2AB, 1 plus 1 minus A square plus B square minus 2A, then minus 2B. Multiplying here means 2AB it is product. C3 is multiplied by A and it is divided by A. So same number again. Here 2 C3 A square we get product by A minus AQ minus AB square multiplied by A. Then C3 implies C3 plus C2. Adding these two. If you add what we get is equal to 1 by A determinant of first column as it is minus B square 2AB, then 2B, here 2AB, 1 minus A square plus B square minus 2A. Here adding minus 2AB plus 2AB we get 0. Here adding 2A square plus 1 minus A square plus B square means what we get here? 2A square minus A square means A square will come plus B square plus 1 added. So it will be 1 plus A square plus B square we got here. Then next A minus AQ minus AB square minus 2A. Then what we get here? A minus 2A minus A minus AQ minus AB square, right? If I take minus A outside here, if I take minus A outside, what will remain? Minus A 1 plus A we have taken outside minus A. So A square will remain. Here also minus A outside plus B square will remain. So minus A in the last element, what will remain? Minus A into bracket 1 plus A square plus B square will come. Because we require right hand side that only 1 plus A square plus B square. So that. Then firstly we made it at 0. Then by the property take it common. What is common in C3? 1 plus A square plus B square is common divided by A as it is determinant. 1 plus A square minus B square. One plus A square plus B square is common divided by A is the determinant. 1 plus A square minus B square 2A, here 2B as it is, here also 2A, 1 minus A square plus b square minus 2a. Here we have taken 1 plus a square plus b square outside. 0, 1, then minus a will be again. You can make it this one as 0. To make it as 0, which operation we can apply? Again multiply second row by a. Multiply second row by a. What happens? R2 implies a into R2. Now, you are multiplying it, you have to divide as 1 plus a square plus b square divided by a, because you are multiplying and dividing by a. Only second row is multiplied by a square. Yeah. 1 plus a square minus b square as it is, 2ab as it is, 0 as it is, second row. Multiplied by a, it will be 2a square into b. Here multiplying by a minus a cube plus ab square. Here a into 1, a, 2b minus 2a, here it is minus a. Then adding that, make it as 0. R2 implies R2 plus R3. R2 implies R2 plus R3. Then only we get 0, which is equal to 1 plus a square, or else okay, 1 plus a square plus b square. Let's go into before that, here a square is there. From C2, you can take a outside. If I take a outside, what happens from C2? A1 a will come, and from C3 also 1a into a. Determinant. Taking common from C2 a common, from C3 a common, because downside a square is there. It is not required in RHS. In RHS only 1 plus a square plus b square whole cube is required. So denominator a square not required. From that, from C2 and C3 we take a outside. So what will remain? Later on we can apply this operation on 2a implies. I'm making 0. 2a square b as it is. 2b as it is. From C2 we have taken a outside. 1 minus a square plus b square will remain. Here minus 2 will remain. Okay, 0, 1, minus 1. 0, 1, minus 1. Then R2 implies here a cancel. R2 implies R2 plus R3. So LHS is equal to 1 plus a square plus b square. Determinant 1 plus a square minus b square as it is, 2b as it is, 0 as it is. Here R2 plus R3. R2 plus R3 means 2a square b plus 2b R2. 1 minus a square plus b square minus 2. 1 minus a square plus b square minus 2. Here 1 minus 1, 0. Here 2b as it is, minus 2 as it is, minus 1 as it is. Simplify and expand through third column. Expand through third column. What happens? 1 plus a square plus b square into 1 plus a square minus b square. 2b 0. What is common here? 2b is common. 2b into bracket a square plus 1. Here 2b. Here minus 1 minus a square plus b square minus 2 0 minus 1. Right? Okay, then you can simplify this, you get the answer. Expand from C3. You expand from C3, you get RHS. Okay. Question number 14. Prove that by using properties of determinants a square plus 1, ab, ac, ab, b square plus 1, bc, ca, cb, c square plus 1. It is also same form. Is equal to 1 plus a square plus b square plus c square required. Again consider LHS. A square plus 1 ab, ac, ab, b square plus 1 bc, ca, cb, c square plus 1. Okay. See here. The right hand side, we require 1 plus a square plus b square plus c square. To make them as a square plus b square plus c square, what we'll do here, R1 implies multiplying by a. First row is multiplied by a into R1. Second row is multiplied by b R2. Third row is multiplied by c. Because we require b square. In the right hand side, a square plus b square plus c square is required. Here already a square is there. Here also required a square. Here also required a square. To get a square, what we will do? Multiplying by a. Similarly, second row, we require here b square plus 1 is there already. Here b square is required. Here also b square is required. That's why. So we have taken the operations like this. Next, if you are multiplying, then you must divide by the same element. Okay. For that, a b c we have multiplied. So a b c divided. First row is multiplied by a. It will be a into a square plus 1. It is a square into b, a square into c. Next it is a into b square, b into b square plus 1, then b square into c. Next c square, third row, multiplying by c square into a, c square into b, c into c square plus 1 is that. Okay. from the first column. Here we multiply first row by A, second row by B, third row by C. So in the first column, I think A is common. Take it outside. From first column C1, take A outside. From C2, B is common. So take it outside. From C3, C is common. Take it outside. So ABC by ABC. Determinant. I take A outside, what will remain? A square plus 1 will remain. Here B square will remain. C square will remain. Here B common, A square will remain. B square plus 1 will remain. Then C square will remain. Here C taken outside. A square will remain. B square will remain. And C square plus 1. So ABC cancel is equal to. Now apply the operations. 1 plus A square plus B square plus C square required. So adding R1 implies R1 plus R2 plus R3 will give is equal to first row 1 plus A square plus B square plus C square. Here also A square plus B square plus 1 plus C square. It means 1 plus A square plus B square plus C square. Right? Here also say A square plus B square plus C square plus 1 means 1 plus A square plus B square plus C square. Is it right? Then remaining as it is B square plus 1, then B square, C square, C square, C square plus 1. Next. Take 1 plus A square plus B square plus C square common in first row. Take it outside. Here 1, 1, 1. B square plus 1. B square. C square plus 1. Again, what will do? Make B square 0. If you make them 0, R2 implies, C2 implies C2 minus C1, C3 implies C3 minus C1. So 1 plus A square plus B square plus C square into 1 B square C square as it is 1 minus 1 0. B square plus 1 minus B square will remain 1. C square minus C square 0. 1 minus 1 0. B square minus B square 0. C square plus 1 minus C square 1. So one side of the principal diagonal, the upper side you get 0. Above the principal diagonal, each element is equal to 0. So the determinant of the value of the determinant is equal to product of principal diagonal elements. Here principal diagonal elements are 1, 1, 1 only. So we get 1, which is equal to RHS. These are some examples based on properties of the determinant. Next, 15th one. Let A be a square matrix. Let capital A be a square matrix of order 3 cross 3. Order 3 cross 3. Then determinant of K into A is equal to what? There is one theorem. The theorem says that if A be any matrix of order n cross n, means n order n, then determinant of K into A is equal to K raised to n minus 1 into determinant of A. This is the theorem. by this theorem, the answer will be what it will be, because the order is 3 cross 3. So n is equal to 3. So by this determinant of k into a is equal to k raised to n minus 1. It will be a square matrix. K raised to n minus 1. K, n is 3 here. N is 3. 3 minus 1 into determinant of a, which is equal to k square into determinant of a. That is it. By using this theorem. Okay. These are some examples on properties of determinants. So, based on this topic, we will ask 4 marks question for the annual examination. Okay. That also in the part E. One is 6 marks question, another one is 4 marks question. B 49th and 50th question. B will be there. 50th, B will be there. Here they will ask either here or here. This question will become 4 marks question. And interchange. Next, this is about properties. Next, the application part. Applications of determinants and matrix and determinants we can call application part here. So in the application, we can find area of triangle by using determinants. Area of the triangle by using determinants. We know the formula. Area of the triangle is equal to, if 3 vertices given, if 3 vertices given, that can be calculated by using this formula. Suppose A is x1 y1, B is x2 y2, and C is x3 y3. These are the 3 vertices of the triangle. Then how to find the area of the triangle? That formula is 1 by 2 x1 into y2 minus y3. In the geometry we studied already, x2 into bracket y3 minus y1 plus x3 into bracket y1 minus y2. This is the formula we studied in geometry last year. So this can also be written as by using determinant. So how to get that? Here if I write x1, x2, x3, y1, y2, y3, 1, 1, 1. If you expand this determinant, again we get this one. Whatever formula was there in the geometry, same formula we get if you expand the determinant. See, if you expand from first column x1 into y2 minus y3, so minus y1 into, minus x2 into, leave this column, row and column, y1 minus y3. If you take minus outside, minus plus y3 minus y1 you get, plus x3 into, leave this row and column, y1 minus y2. So this is the formula for using determinant for calculating the area of the triangle. We need to remember this formula. Okay, we'll see some examples. So this is the area of the triangle, delta we can write. We'll see some examples to find the area of the triangle. Here some more points are there, we need to remember. So here, for collinear, To prove ABC vertices are collinear or ABC are collinear points, to prove that we can write delta is equal to 0. Delta means area of the triangle. If area of the triangle is equal to 0, then we can say ABC are collinear. This is first point. And second point is, if they give area of the triangle somewhat k square units or n square units, something they will give. They used to find, they will ask, find any one vertex we need to find. That is somewhat they will give first vertex A, second vertex B, 3, 4 like that. Suppose C is equal to 1, k. We need to find this k. In such situation, what we use, we consider plus or minus. Whatever the area of the triangle they have given, so we get k value. 2 values we get for k. Okay. This is second point. If only vertices they will give, area will be only positive, because always area will be positive. That's all. Third point is, if they give the vertices, then area of the triangle is positive. If they give area of the triangle, then ask to find k value in case that we need to consider area of the triangle as plus or minus. Okay. These are the 3 points we need to remember. By using this formula, let's solve the examples. Find first question, maybe 4.3. First question. Find the area of triangle. Find the area of triangle with vertices at the point, given in each of the following. Okay, so first one, 1, 0, 6, 0, 4, 3 is that. Here means vertices they have given, they are asking to find area of the triangle. So let us consider it as A, as B, as C. These are the 3 vertices A, B, C. The area of triangle ABC is equal to half into determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay. Now consider it as x1, it has y1, x2, y2, x3, y3. What else? Which is equal to 1/2. x1 means 1, y1 is 0, is 1, 6, 0, 1, 4, 3, 1. Now, for simplification, let us consider second column, expand to second column because it will be easy for calculation. So, if you expand, what happens? 1/2 determinant. Here negative, positive, negative will be there. So -3 into bracket. This will be 0 only. -3. Leave this column. So row and column. 1 minus 6. 1/2 minus 3 into -5 5 3s are 15, 15 by 2 square units. This is area of the triangle. Next example, same time, 2 comma 7, 1 comma 1 and 10 comma 8. Same type example, same formula. Here let us consider x1, y1, x2, y2, x3, y3. You get the answer. Substitute here and simplify. You get the answer. Area of the triangle. We consider A, B and C. 1 by 2, determine x1 is 2, y1 is 7, then 1, 1, 1, 1, 10, 8, 1. Okay, then apply the operations also. R2 minus R1, R3 minus R1 for easy way for simplification. Okay, and these two will be 0, otherwise directly you can expand it, then that's no problem. Or else R2 minus R1, R2 implies R3 minus R1. It will be easy for simplification. 1 by 2. First 2 as it is, 2 7 1. Here. See, 1 minus 2 minus 1. 1 minus 7 minus 6. 1 minus 1 0. 10 minus 2 8. 8 minus 7 1. 1 minus 1 0. So now we expand from third column C3. You expand, you get the answer. Minus 12 plus 7. Okay. Simplify this, you get the answer. Okay. One more example, we give proper one. Minus 2 comma minus 3, same. Find the area of the triangle. 3 comma 2 minus 1 comma minus 8. Simplifies. Okay. Remaining examples, see in the next page. And one more topic is that finding minus and cofactors. That is also on the area and the applications of determinants. So after that minus and cofactors, we can find inverse of the given matrix, inverse of the given square matrix. That will see tomorrow from the next paper. Thank you.